In this lecture, we are going to study the F distribution and the F test. Let x11, x12, so on x1, n1 be a random sample from a normal population whose mean is mu1 and variance is sigma 1 square, and x21, x22, so on x2, n2 be a random sample from a second normal population with mean mu2 and variance sigma 2 square. Assume that both normal populations are independent of each other. Let s1 square and s2 square be the sample variances. Then the ratio s1 square over sigma 1 square over s2 square over sigma 2 square, which is denoted as F, has a F distribution with n1 minus 1 numerator degrees of freedom and n2 minus 1 denominator degrees of freedom. This result is based on the fact that n1 minus 1 s1 square over sigma 1 square is a chi-square random variable with n1 minus 1 degrees of freedom, and n2 minus 1 s2 square over sigma 2 square is a chi-square random variable with n2 minus 1 degrees of freedom, and that the two normal populations are independent. Next, we state the null hypothesis, the test statistic, alternate hypothesis, and rejection criteria as follows. So here the null hypothesis for a F test would be H naught as sigma 1 square equals to sigma 2 square, and the test statistic is defined as F naught equals S1 square over S2 square. So then the alternate hypothesis and the rejection criteria are defined as follows. So here we have the alternate hypothesis and the rejection criteria. So for a two-tailed test, the alternate hypothesis will be sigma 1 square not equals to sigma 2 square, and the rejection region will be all f naught greater than f alpha over 2 nu 1 nu 2, or f naught less than f of 1 minus alpha over 2 nu 1 nu 2, where nu 1 and nu 2 are the degrees of freedom of the two samples considered. Nu1 is equal to n1 minus 1 and nu2 is equal to n2 minus 1. For a right-tailed test, the alternate hypothesis is sigma 1 square greater than sigma 2 square, and the rejection criteria would be f naught greater than f alpha nu 1 nu 2. So that is, if f naught is greater than the critical value at alpha level of significance and nu 1 nu 2 degrees of freedom, then we are going to reject the null hypothesis. For a left-tailed test, the alternate hypothesis is sigma 1 square less than sigma 2 square, and we will be rejecting the null hypothesis if the test statistic calculated is less than f1 minus alpha nu 1 nu 2. Next, we will see the region of rejection for the three types of tests we have come across. For a two-tailed test, the region of rejection lies on both the tails, that is right tail as well as the left tail. So the critical value on the right tail would be f of alpha by 2. So anything beyond f alpha by 2 constitute alpha by 2 percentage of the scores of the distribution, and anything below f of 1 minus alpha by 2 constitutes the other alpha by 2 percentage of the scores of the distribution. So in totality, both on the right and the left tail, it would constitute alpha percentage of the scores of the distribution. Whereas for a right-tailed test, the critical region lies on the right side of the critical value f alpha, that is alpha percentage of the scores lie above f alpha, and for the left tail test, the critical region lies on the left tail, that is anything below f of 1 minus alpha constitute alpha percentage of scores of the f distribution. So herein we can constitute a relationship between f alpha and f1 minus alpha. Suppose I need to find f of 1 minus alpha with nu 1 degrees of freedom in the numerator and nu 2 degrees of freedom in the denominator. I could also find this by taking the reciprocal of f of alpha nu 2 nu 1, where f of alpha nu 2 nu 1 has nu 2 degrees of freedom in the numerator and nu 1 degrees of freedom in the denominator. The first problem reads, two random samples taken from two normal populations yielded the following information. N1 is 11, N2 is 8, S1 square is 61, S2 square is 44. Find the statistic F and test the hypothesis H0 sigma 1 square equals to sigma 2 square against the alternate hypothesis sigma 1 square greater than sigma 2 square at 5% level of significance. Given f of 0.05, 10,7 equals to 3.64. So based on the alternate hypothesis, we can say that it is a right-tailed test. So we need to calculate the statistic f, which is given as s1 square over s2 square. Substituting the value 61 over 44 gives us the value as 1.39. So we are going to compare this statistic 1.39 with f 0.05. So we do want to check whether it is greater than f 0.05, which is 3.64. Certainly 1.39 is not greater than 3.64. That means we do not reject the hypothesis. Do not reject, or in other words we can say accept the hypothesis. The next problem reads like this. Two random samples taken from two normal populations yielded the following information. N1 is 10, N2 is 13, S1 square is 12, S2 square is 23. Find the statistic F and test the hypothesis, the null hypothesis sigma 1 square equal to sigma 2 square against the alternate hypothesis sigma 1 square less than sigma 2 square at 5% level of significance, given F 0.95, 9, 12 to be equal to 0.3257. So calculating the F statistic using the formula S1 square over S2 square, we obtain 12 over 23 as 0.5217. So here based on the alternate hypothesis, we can see that it is a left-tailed test. So we do want to compare this F with F 0.95. We do want to check whether this is less than. So F is equals to 0.5217 or just 52, and F 0.95 is 0.3257. So we do want to check whether 0.52 is less than 0.32. So certainly F is not less than F 0.95. That means we do not reject the hypothesis, or in other words we are going to accept the hypothesis. The next problem reads like this. One of the quality measures of blood glucose meter strips is the consistency of the test results on the same sample of blood. The consistency is measured by the variance of the readings in repeated testing. Suppose two types of strips A and B are compared for their respective consistencies. Suppose 16 type A strips. So N1 is equals to 16 and 21 type B strips. N2 is equals to 21 are tested and the sample variance are found to be 2.09. That is S1 square equals to 2.09 and 1.10 respectively. S2 square is equals to 1.10. Assume the glucose readings using type A and type B strips follow a normal distribution with variance sigma 1 square and sigma 2 square respectively. Test at 10% level of significance. So alpha is equals to 10% or 0.10. Whether the data provides sufficient evidence to conclude that the consistencies of the two type of strips are different. Given f 0.05 2 equals to 2.20 and f 0.95 equals to 0.43. Okay, so we have all the data written down. So the null hypothesis will be h naught is sigma 1 square equals to sigma 2 square, and the alternate hypothesis would be conclude. So here this gives consistency of the two types of are different, that is sigma 1 square not equals to sigma 2 square. So from this we can see that it is a two-tailed test. So here the graph would look something like this. So anything above f alpha by 2 we are going to reject, and anything below f 1 minus alpha by 2 we are going to reject. So here alpha is equals to 0.10, so alpha by 2 would be equals to 0.05, and they have given that f 0.05 is 2.20 and f 1 minus 0.05, that is f 0.95 is 0.43. So now let us calculate the statistic f using the formula s1 square over s2 square, which is 2.09 over 1.10, which gives us the value as 1.9. So we do want to compare this f with f 0.05. We do want to check whether f is greater than 0.05. Here f is 1.9, f 0.05 is 2.20. Certainly 1.9 is not greater than 2.20. So we do not reject the hypothesis, do not reject. And also f we are checking whether it is less than f 0.95. F is 1.9 and f 0.95 is 0.43, and certainly f is not less than 0.95. So therefore we do not reject the hypothesis. And on the graph you can see that 1.9 would be somewhere here. So this is the region of acceptance. So 1.9 is falling in the region of acceptance. So we do not reject the hypothesis. The next problem is as follows. Oxide layers of semiconductor wafers are etched in a mixture of gases to achieve the proper thickness. The variability in the thickness of these oxide layers is a critical characteristic of the wafers, and low variability is desirable for subsequent processing steps. Two different mixtures of gases are being studied to determine whether one is superior in reducing the variability of oxide thickness. 16 wafers are etched in each gas. So N1 is equals to 16, N2 is equals to 16. The sample standard deviation of oxide thickness or S1 is equals to 1.96 angstroms and S2 is equals to 2.13 angstroms. So here the standard deviation is given, not the variance. Is there any evidence to indicate that either gas is preferable? So that means is one gas preferable over the other, or is gas A preferable over gas B, or B preferable over gas A? So here they're asking us to use the F test at alpha is equals to 0.05 level of significance. So we want to check whether the population variances, or that is sigma 1 square is greater than sigma 2 square, or sigma 1 square is less than sigma 2 square. or in other words we want to check whether sigma 1 square is not equals to sigma 2 square. So this becomes our alternate hypothesis, and the null hypothesis is always sigma 1 square is equals to sigma 2 square. So here this is a two-tailed test. This is a two-tailed test. So the graph would look like this. So anything above f alpha by 2 will be rejected, and anything below f1 minus alpha by 2 will be rejected. Alpha is equals to 0.05, so alpha by 2 would be equals to 0.025. So therefore f 0.025 at 15 degrees of freedom in both the samples is given as 2.86, and f1 minus alpha by 2, which is f 0.975 at 15 degrees of freedom in both the samples is given to be equals to 0.35. Okay, so this f alpha by 2 is 2.86, and f1 minus alpha by 2 is 0.35. So now we can calculate the test statistic f, which is s1 square over s2 square, which is 1.96 the whole square over 2.13 the whole square, and it is found to be equals to 0.85. Okay, so here 0.35, 2.86, 0.85 would be somewhere here. So that means we are going to accept the hypothesis. But let us compare this with f and f 0.025. So here f is 0.85, and f 0.025 is 2.86, and we are checking whether f is greater than, and certainly f 0.85 is not greater than 2.86. So therefore we do not reject the hypothesis. Similarly, f and f 0.975 is compared, and we do want to check whether f is less than. F is 0.85 and f 0.975 is 0.35. Certainly 0.85 is not less than 0.35. That means we do not reject the hypothesis. So therefore do not reject the hypothesis. So that means to say that there is no strong evidence to indicate that either gas is preferable.